Impulse momentum theorem problems. Now, to calculate the impulse force, you have to use three basic different concepts. One is when force is constant for a finite interval of time. When force is a constant for a finite interval of time, then change in impulse is equal to force into T2 minus T1. This is the first case. In second case is when force is a function of a time. When force is a function of time, in that case, change in impulse is equal to integrate f from t1 to t2. The limits are t1 to t2 and we have to integrate the f with respect to time t. So we can write integration of t1 to integrate from t1 to t2 f into dt. Then third one is when force is very large and time interval is very small. In that case, impulse equal to force into delta t, where delta t is the short time of interval. Here or many times the problem was asked on this concept when force is constant for a finite interval of time. Let's see the problem. The block of mass 50 kg is initially at the rest and which is acted upon by force P when P varies as shown in figure. The force to time diagram is given. It varies as shown in figure. If mu between the block and the surface is 0.20, find the velocity of a block when t is equal to 5 seconds and t is equal to 10 seconds. FT diagram or PT diagram, force versus time diagram is given, and also a block is given whose mass is given as a 50 kg. The coefficient of friction is given because when the block is acting towards the right, the friction force will act towards right, and that is equal to mu and nt. So impulse is nothing but area under the force t diagram. So we have to calculate first velocity at 5. So we can write impulse at 0 to 5 is equal to momentum at 5 minus momentum at 0. Now block is at the initially at a rest, so momentum initial will be 0. Now we'll calculate impulse at 5, and that is equal to area under PT diagram or area under force time diagram. So we have to take area of this, and that is equal to 250 into 5. So that is equal to 1250 Newton sec. But for this impulse, friction will create in opposite direction. So that is equal to, that's why it is, the friction force is acting towards the left, so it is shown by minus sign, and magnitude is equal to mu n into t. T is the time interval. So that is equal to minus 0.2 into 50 into 9.81. 50 is a mass which is given in kg, so that's why I multiply by 9.81 into t is the time lag, and that is equal to 5, which will get 490.5 Newton second. We want net impulse force from 0 to 5, and that is equal to 1250 minus 490.5, and we'll get net is equal to 759.5 Newton second. Now momentum calculation. So momentum at 0 is 0 because blockage starts from rest. Initial rest condition is given. Now m5 is equal to, momentum at 5 is equal to, momentum is basically mass into velocity, so that is equal to 50. 50 is the mass, 50 kg is given, so 50 into v5. So we can use by the formula I0 to 5 equal to m5 minus m0. Net I we have found out in this step equal to 50 into v5 minus 0. So therefore we will get velocity of 5 is equal to, at 5 is equal to 15.19 meter per second. Now we need to find out velocity at 10. So we have to find out I5 to 10 is equal to m10 minus m5. Momentum at 10 minus momentum at 5. So we'll find out impulsive force. Now area under in PT diagram or area under FT diagram, from this portion we have to take from 5 to 10. So we have to take this area of a triangle, and that is equal to 1 half 5 into 250 is equal to 625 Newton second. But friction will opposite, so we'll deduct that frictional effect, and that is equal to minus mu nt. Again it is minus 490.5. So net I5 to I10 is equal to 134.5 Newton sec. This is impulsive force. Now momentum at 5 is mass into velocity at 5. So mass is 50, velocity to 5 we have found out in earlier step, and so we'll get m5 is equal to 759.5. Then we need to find out m10. M10 is nothing but mass into velocity at 10. Mass is 50, velocity 10 is unknown. So we'll use the impulse momentum theorem and we'll write I5 to I10 is 134.5 equal to 50 into V10 minus m5 value is 759.5. After solving that, we will get velocity at 10 is equal to 17.8 meter per second.